recording. Okay, so basically we've gone through at the last step during this semester. So basically this is functional programming, and there is a topic on lambdas now. And the last one will be on streams. So that will be it for the Java technologies this semester. Of course, you have still to deliver task 1, task 2, and task 3. On task 1, I see that couple of answers I think I've already given, but nothing yet responded. On task 2, there are 4 jobs I need to check, and on task 3, there are no new submissions. So basically, I do have a little bit of work to do in front of me, and you still have a couple of weeks to submit your jobs, your homework. So as a reminder, task 1 has to be completed in order to get access to the exam. Okay, so these are the usual things. By the way, server for the task number 3 was down. Just before the lecture, I have lifted it up. Okay, let's go to the lecture. So today we will be looking into the lambdas. So basically, this is the feature of Java that was included in version number 8. And basically, we will look into the simplification of anonymous functions, plus functional interfaces that actually allow to fulfill the lambda, actually to construct the lambdas. Then we will look into the functional interfaces that are provided by the Java API itself, scopes, and some additional ways in order to simplify your code. These are called method references. So again, what we've basically been looking at during this semester for the Java technologies is basically the imperative programming, which implies that you have to write all the instructions for the program to be executed. So if you want to iterate, you just don't tell that you want to get something out of the iteration. You just tell that, okay, start from 1, 2, 3 until the end, and if something is equal to something, then you just return and so on. So you basically command. You write a program that is imperative. So there are a bunch of various paradigms for the imperative programming, like procedural, the object-oriented, which we looked at, and obviously we looked at the encapsulation, composition, delegation, inheritance, and polymorphism. All these things we were talking about during the semester. So basically, the concept of functional programming is coming from the different paradigm. This is the paradigm of declarative programming. So basically, in declarative programming, you do not command right from the beginning, but you just declare what you want, what result you expect from the instruction. So for instance, if you're about to look for the value in the collection, you just basically construct a function that returns it. And so you name a function that, for instance, get me first, that would match some kind of the predicate, and so on. So basically, we will talk about this. As an example, for the functional programming, basically, you can consider, not functional, but with declarative programming, you can consider, for instance, logics languages or SQL language, where you declare the final result, and you just rely on the mechanism that it will construct the right procedure in order to extract results. Okay, so talking more about the functional programming, there are some good things that come with that, with this programming style, and this is totally related to the multi-threaded programming. So this is not a new paradigm. This is not the new programming style. It was right from the beginning of a programming, because it is actually following the usual mathematics when you have function compositions. We've been looking into these during the data analysis as well. But this becomes more and more appropriate in the world of multi-threaded programming, because what the functional programming brings into the scope of programming is that it does not have or avoid the mutable state. As you recall from the multi-threaded programming topic, the largest headache in programming for the multi-threaded environment is basically synchronizing the state of some value that you are accessing from multiple threads. So if the programming style avoids it from the very beginning, it is just much simpler at the end. So for instance, when you are constructing some structure, some execution tree for the neural nets, and you follow the functional programming paradigm, you have a tree which can be executed, each branch can be executed separately, and it does not depend on any mutable state. So it can be splitted, the tree can be splitted into multiple threads, multiple processes, processors, GPUs, etc. So this is the actual meaning of a tensor. And TensorFlow, what it does, it is capable of splitting the whole execution of some tensors or functions into unlimited set of the parallel execution threads. So basically, avoiding mutable state allows it right away. Then functions as first-class values, meaning that as an argument you can pass a function, right? So basically, function can be passed as a pointer to some functionality. Higher order functions is basically constructing functions out of a function, so basically calling inside. So these are the compositions. And the declarative style, basically you name your functions up to the result that you are expecting. As well, what's important that all the functions in a functional programming style are actually very stable. So basically, given an argument x, the function f will always return the same result. So basically everything it relies on is just the arguments that it receives. So no other dependencies for the function exist. This is not totally true, not 100% true with the Lambdas in Java, but it tries to follow the style, right? So basically there are some limitations in Java, but Java tries to include Lambdas as a way to actually to mimic, to follow the functional programming style. Okay, so it was included in Java Standard Edition 8, and basically Lambda is coming from the Greek letter, obviously, and represents a function from the Lambda calculus. And this is basically, as you can see, it is basically, as you will see, this is basically a concise way to represent the method interface. Okay, so we will start from the example. So as a simple example, we will take the comparator, right? So you can imagine that, for instance, we have a arrays.sort static method, which basically accepts a couple of arguments. One argument is an array, another argument is a function, which provides a functionality for the array to be sorted in one way or the other. So basically, up in the beginning, we just don't know which way we would like to sort the array of t's. This is the generic, this is the type parameter. So we basically, we allow the user of this array sort static function method to basically pass the functionality. So this piece of functionality is to be passed by the user. And what actually allows us to do so, it is the interface. This is the public interface from Java API, which does nothing except by comparing two values. So basically by comparing two values, it returns 1 if argument 1 is bigger than argument 2, 0 if these are two equal, and -1 if it is vice versa. Okay, so basically this kind of simple interface provides a way for the programmer to plug in the functionality, basically to change the behavior of this array sort. So what you can do, what you can consider from functional programming style, that array sort is the higher level function that accepts a lower level functionality inside it. Right, and as you can see, this comparator, if it is correctly constructed, it should depend only on these two arguments, nothing from the side. Okay, so right now, without lambdas, without considering lambdas, we have a couple of ways to do that. So one way is basically to declare a class, which, for instance, would be called by name length comparator, right? So you see this class that implements the comparator, and this is the method it implements. So after doing so, quite a lengthy declaration, we can use this as a separate instance of by name length comparator. Okay, so this is the usual old school way. The more concise way is, if it is not to be reused anyhow, what we can do, we can declare it right away. We can use so-called anonymous class. So this class that we initialize here by the keyword new will not have any name in the system in the Java virtual machine, but it will be used and utilized right here. So the comparator will be created, it will be passed as an argument. So this is the way we can pass the functionality. So the problem here, both declarations are quite lengthy, right? They're quite lengthy. And since we already know we're about to pass the comparator, we know the type of this guy, right? Because we're passing an array, so we know what type of the elements this array is for. So we basically know a lot, and all this declaration is to be considered as redundant in lambdas, and we will start stripping it out. Okay, so let's start from step number 1. So we consider this to be a monstrous anonymous class, right? The second option, this is an anonymous class. So what we can do, we can strip out everything from the initialization of an object, all this method name, etc., and we can take only the arguments and the body with the return statement, right? So we basically remove these guys, and what we leave with are just the definition of the arguments, because we need to pass names, because these names are used in the body. And then this is the arrow, right? This is the arrow, and this is the body. And in the body, we just return whatever we compute over here. Okay, so this is this stripping out the anonymous class. So these are the examples of totally valid lambdas. We have a definition of the arguments to be put into the into the single function of the interface, and this is interface body. So this is comparison by age, this is comparison by length, and this is a more this is a more difficult, more complicated comparison. Okay, so this is an example where we just stripped on the first level. Okay, now let's strip these declaration of the types, right? Because types we know as well. So why do we repeat these types? Because the types are coming from the definition of the interface, right? So we can get rid of the argument types, and it becomes like this: P1, P2. We know that this is a person because this is definition from the interface, and the body remains as it was. So this becomes even more concise. So we have the argument names, and these names are being reused over here. So this is level 2 stripping. And level 3 stripping is basically, we don't need a return statement, because return statement is, if it is a single line execution, so we can basically get rid of return and get rid of these brackets, right? So we basically remove them, and what we are left with is the definition of the names plus the execution. So if it is a single line, we don't need to do anything more. And this is, again, this is the simple execution. This is the simple comparison. This is another simple comparison, one-liner. And this is a more complicated comparison. So we need a return statement. We need to specify some variables inside, do some ifs, etc., additional blocks. If our function is a little bit complicated to be put into the one-liner, then we just basically have it in a more elaborated way. Okay, so for instance, where lambdas can be used and are quite effective. So basically, for instance, in various GUI programming options. So for instance, we have a button, and each button accepts an action listener, because in a GUI, each button needs to have some action listener where it performs a certain action when it's pressed, for instance, or dragged, or done wherever. So basically, before Java 8, we had to implement new action listener, and this action listener had a single interface, action performed, and so on. So basically, this was 1, 2, 3 actions for the button. And as you can see, what's meaningful there is just the button set background, the JPanel, some message box appeared, and so on. So in Java 8, it becomes much more concise. It becomes just E as an action event argument, and then something which is required for the functionality of your button press. As you can see, much more concise, lots of garbage is being dropped. Less verbose, more readable. Okay, let's take a look into some examples. Maybe I do have something to show you. Okay, so these are the examples you can access as well. So basically, here we have an example where we have a class comparator, right? Just like in the slides. And here's a huge main method. We have array of persons, array on persons. So basically, we sort by the class. This is anonymous. Then we start stripping it out. So this is the first level lambda, right? This is the second level lambda. So we got rid of these names, of these type definitions. And somewhere, right, this is the third level lambda, right? This is the third level lambda. Okay, I was able to put this function, which was in slides and on a few lines. So this is in a single line, right? Everything put into the single line. Okay, sorted by name and age ascending. Okay, it is sorting by a couple of fields. Okay, so let's try to execute run. So it basically sorts, right? Nothing else. Okay. So it sorts by name, sorts by age, sorts by age, descending, sort by name, descending. These are automatically generated, randomly generated persons, and sorted by name and age. Yeah, okay. So basically, these are examples taken from the slides. You can execute them, you can investigate them in more, however you want. So this is an example of this button press on a G-frame. So basically, this is GUI programming in Java, right? So we have a J-frame, and we have an action on a button. So this is old school way. And this is a lambda way, right? So lambda way is much more concise, with just basically 3 lines. And here we had to implement all the functions required. So basically by executing that, we should get some window popping up. Yeah, we just got a window popped up. Test button, it becomes red, becomes green, right? Just because lots of actions now are being hooked on this button. So that's the reason why it flips these colors. Okay, let's take a look. Okay, so these were basically examples up until now. So let's go a little bit forward with the slides. So what you looked at here in this example, all the definition of the name, return type, arguments, everything is coming from this simple interface. And as you can see, since we have stripped everything, right, we have stripped all the complexity. So it is required that the interface, which is about to be used, would have a single method. Single method is required. Because what if we would put a separate, another method, if it would have compare and, for instance, compare inverse or something like that, it would basically break the rule. So here in the lambda expression, it would not know which method to be used right there, right? Because the interface might have a few methods. So in order for this not to happen, it is required that for lambda to be used, a single method interface should be declared. So these interfaces are called one method interface, functional interface, or single abstract method interface. And just like in override, we can put the declaration on the interface that it is a functional interface. It is not mandatory, but it's recommended. So basically, we have an interface like this, and it is intended to be used as a lambda. So basically, we put functional interface. And if some programmer would be willing to put another abstract method here, it would automatically not compile, and compilation will be broken, right? So basically, design as intent and so on. Okay. So these are the examples. So basically, we declare intent that for calc method in my function interface, we will use this as a lambda. So no other no other functions, abstract functions are allowed, right? And there we can use it. So my function is accepted and calc. So basically, we provide some additional functionalities for our upper level function, right? So upper level function is basically sum of, and the simple function, which is provide additional functionality, is this f argument. Okay, so basically this is the usage, and this is how we can use it. So sum of, this is a basic execution of the integral. So integral, we provide a function for the integral, and this is a range from a to b, and this is a step. So basically, for calculating the integral, we basically move from a to b by the step, and we sum up results of the function. So here we can provide for this integral, we can provide the function, and function as a lambda is very convenient. X times x, 10 divided by x, and so on. We just basically throw in various functions, and we expect that these functions will be integrated in a range with some step. Okay, so I think you understood that you can specify any interfaces, and you can specify them as functional interfaces. So compiler will control that they have only one abstract method, these interfaces, so then you can reuse them as lambdas. Otherwise, it would break because system would not know how to actually use it. Okay. So yeah, this is just exactly the same thing. So we have a functional interface defined. We have my function, right? We have some function. And we have integrate method, which accepts some function, right? And we can basically throw in various functions like squared, like this, like on, and so on. And these functions will be integrated. So let's run it. Okay, and expect something back. Okay, these are various examples of integrations. So square integration between minus 10 until 10, step number 10. And since more and more steps we have added, so integral becomes more and more precise, obviously. Right, so, okay, so these are the integrals, more and more precise, and so on. So we have various functions integrated over there. Okay. So for instance, if I would try to define, here is my functional interface, I will try to define it, for instance, another method, right? So calc1, for instance, right? So it automatically will not allow because multiply note overriding abstract methods found in interface sum function. Okay, so this basically prevents me for breaking out the rule for lambdas. So we can remove that, for instance, and now lambdas will basically break as well because they have two functions, right? So basically I can put something like a double y. So double y. Anyway, they are not compiling because it has a couple of abstract methods and this is not allowed, right? Okay, so basically functional interface is considered such an interface which have one abstract interface here defined. So now it's all okay. All right. Okay, I hope this is okay with you. Let's move on. Functional interfaces. Okay, so basically these functional interfaces are being used throughout in Java. So instead of writing some specific functional interfaces, Java API along with Lambdas has provided the generic interfaces for all the generic cases, for most of generic cases, right? So basically to have all purpose and reusable backbone for Lambdas. Right, so we have two types. We have typed interface, generic interface, and basically the combination of the two. So, for instance, typed interfaces have the as an argument and as a result some primitive type. So basically, there are unary operators that accept one argument and return one argument. Right. So, for instance, double unary operator is a function which accepts one double in, one double out. And the same is with integer, with longs, right? With two binary operators, two in, one out, right? So all these are specific cases. Two doubles in, one double out. Two integers in, one integer out. Two longs in, one long out, right? So these are generic cases that can be used in various occasions throughout the API. So these are the predicates. So something is in. So for instance, double is in and return is a Boolean. These kind of functions are called the predicates. So integer in, Boolean out. Long in, Boolean out, right? And these are consumers. So for instance, consumer, something is in, nothing is out. So basically void. Double consumer, integer consumer, and long consumer. These are the special cases. So for instance, previously we have defined our own functional interface. And here we just, what we do, we replace with one coming from API. So we have double unary operator, right? So it accepts f double as an input and returns double. So basically here we call the only abstract method apply as double, right? Apply as double. So it's applied, I is being put as an argument and something it returns and puts into the sum. And it works right away like before. And there are lots of other typed functional interfaces that you can see. Oh, this is the usage. So actually, if you would look into the Java API, you would see that these kind of the functional interfaces, generic functional interfaces, are used throughout the API. So as you can see here, some API coming from Java, and you see that there's double binary operator to be put in, integer binary operator, integer unary operator, and so on. So all these are coming from the functions package, the generic ones. Okay, so obviously, since we had the typed interfaces, so we do for the object. So these are the generics, right? Again. So for the predicate, we have an instance of t coming in and Boolean out. We have a function of t coming in and r as a return coming out. Consumer t in, nothing out. Supplier, nothing in, t out. So if you want to generate some values, you basically can generate t's of t-type values. Binary operator is basically taking two t's in and one t out, and so on. And there are more cases like that. So this is basically the predicate from the example. So we have a collection, right? And we want to find first. What kind of first, right? What kind of first? So this is the more or less functional definition, right? So what kind of first is being told by the predicate right there, right? So we basically pass a piece of functionality into the function, right? So this is what this find first is capable of. It basically loops over the collection and tests the predicate. And once the predicate actually tests true, then it returns whatever it tests true, right? So this generic function, find first, basically can be put into like this, find first person, right? So we basically pass a functionality, find first, like this, find first, and basically returns these things. Oh, nice. So this is the generic way of writing it down. There are lots of combinations of these interfaces, so you can look it up, right? And basically combinations between typed and not typed. For instance, to double function, right? Accepts an object, returns a double, and so on and so forth. All right. So basically, along with that, what we get if we use the functional interfaces coming from the API, we get some additional benefits that allow us to compose these functions into the chains or higher order functions. So, for instance, we have a predicate name from A, so we can have a function with the name put into the variable, obviously, right? So this predicate is basically checks that a person starts with A or not, right? It returns true or false. So we can look it up for the person like that. And here we just can basically extend this function, right, by putting and. And this is the default method which is put into the interface. So basically the interface coming from API has a bunch of the default methods that provide some additional functionality and allow to chain or compose the higher level functions from name from A and age more than 20, right? So we accept more than 20, or we can reverse the predicate, so negate, right? Negate. Or we can put an or, right? An or this evaluates true or this evaluates to true. Right, so basically lots of combinations are possible with the default method usage. Okay, and there are some more sophisticated usages. For instance, we have a square double unary operator where we accept a double as input and double as output, right? So basically, this would return 4. So we can create a function that in the chain, for instance, with square dot, and then after you have computed that, and then you call another one, right? So this is 4. And this is 2 times 4, right? This would return 8, right? This would return 8 because these two functions would be calculated in a chain. And this one, compose, basically would calculate that one before the square function, right? So compose method does it that it takes 2 times 2, it's 4, and then this 4 squared, this would return 16, sorry, 16, right? And this is unary operator, this is dot identity, it basically returns always the same value that was put in. So you just basically modify the behavior. Okay. So let's go into the examples now when we talk about the scope. Yeah, so basically we had an example where we have defined our own function to be a functional interface and used throughout in Lambdas. And here's an example where this was replaced with double unary operator, right? With double unary operator, as you can see, it has an abstract method, which is not implemented. And along with that, it has a bunch of default methods like compose and then identity, right? At least these, right, are possible for the high level function construction or chaining functions. Okay, so functionality would be just the same as integration, right, of the function provided. This is again integration. This is an approximation of something, right? These are the examples basically of the same sort. Okay. Just like an example, just we saw before. This is the same example actually. I just put in. Okay. Then number 5 are unary operators. Okay, binary operators. These are various examples of the functionalities. Yep, these are various demonstration of various functionalities, basically, coming from the Java util function package. We can execute that, no problems. See, it's working. Yep, lots of stuff has been put out. So these are demonstrations of these things. Okay. So this is find first person by name. Okay, this is an example how we can move into more and more abstract form of a function. So this is basically find first person by name. We have constructed a function which looks in the list of persons. Person is just a collection of objects, right? So basically looking for the first person by some name, right? So W is being checked that equals ignore case, right? So W as a name. And then we start constructing more and more abstract version of this function. So basically we started with this very specific function, right? And then we moved into other specific function, for instance, find person by age, right? So we now have 2 specific functions that are looking for the specific thing for the name and age. Then we said, okay, why don't we combine these into one version? So we got rid of these 2 things and we just constructed a function which finds the first person which matches a predicate. This is a good reason why we can just get rid of 2 functions, 2 methods, and have a single one, right? Which just loops and checks for the existence for the predicate to return true, right? That's why a good reason we can use that. And this was specific for a person, right? For the collection of persons. And that one, I guess this is the last option, right? The last version. It is just looking not for the third person, but looking for a first item in the collection that matches the predicate. So this is a very generic thing. It basically loops the collection and checks the predicate. So this is how we have made a more abstract version of the same functionality. So this is basically usage of the very specific guys. This is usage is already the single find person, right? Where we passed some piece of functionality in. And this is just find first, right? Where we have reused the generic version of it. Okay, so basically run, and these are more options how we can pass it out. So we just made an abstract functionality and we have reused by passing some piece of function inside. Okay, so basically by Lambdas, it's a very concise way how we can do that. It's quite good to read, no problems to read, no problems to understand. We don't need to put all these anonymous functions, implementations, etc. It's very convenient to do it. Okay. Get person by get average person age, some calculation, right? An average person. This is, I think, the more elaborated example of the same approach. Get average of person name length. So name length average we are calculating, and then moving to a more abstract way, get average of person. What average we are calculating? So basically there is a functionality. We have again the collection of persons, and this function returns the average person age. This function returns the average name length. And this is just calculates average of something. And what is it? It is returned from this function, right? So basically what it does on each iteration, it calls the function, right? And it extracts some value out of it. Either it would be age or the name length. It is defined from above, from this small function. Okay, so this is the generic version of that, right? So basically this is a generic version of that. Now this is even more generic version of this functionality, where we have not only the checkup, right, but the checkup, the retrieval of information which we are about to average, but as well we have a mapper, right, which maps this value to sum, right, and this is the summator. This is the summator that applies some additional functionality on top of already on what was summed up. Right. So as you can see, we have come up from very specific implementation of a function to very generic, right? But lots of functionality need to be given from above. So for instance, these are very specific function usages. These are already providing what to retrieve from the person. All right. This is we're telling on the generic function, right? And this is a way how we can construct just exactly the same functionality, but we defined what we want to retrieve. We define how we want to actually accumulate data. And this is the functionality, how we want to calculate the final value, right? How we want to average it actually. So this is the retrieval of data. This is the accumulation, and this is the final value, final metric calculation. So this actually functionality follows map reduce paradigm. So it can be split into multiple processors used on multiple CPUs, GPUs, or even computers, right? Because with everything what depends on that is being given from the function. Okay, so we can basically run it and results should be identical. Yep, so basically this is average person age, this is average name length. So all these versions of a function are actually execute and compute just the same result. Okay. This is the consumer and supplier example, right? So basically what consumer does, string builder, okay, random, okay, the supplier basically generates a random person. This is a function that accepts nothing and generates a person. So each time you are calling a supply, it basically generates a person. And the consumer, it accepts a person, returns nothing, right? What it does, it appends something and so on. So get name is empty. If name is not empty, it basically accumulates all the first characters from the names, right? Yes, it accumulates to the string builder all the name characters. Okay, let's take a look. I think it will run forever. No, it will not run forever. Okay, basically it has accumulated from the collection all the first name. Line is too long. Okay, line is too long. All right. So basically this is an example of a consumer and supplier. All right. Okay. So basically the Lambda scope, or what a couple of more things to remember. Lambda does not introduce any new scope. So basically it accesses the final variables. So whatever in the scope is final and accessible, so it can access, for instance, consumer can access this process within the scope of some class and instance, of course. It is legal to access local variables. So basically, if this is a local variable, you can access. And of course, since it has an access to the local variables, you can't redefine them, right? So not legal to use the same names, right? You just redefine the name, reassign the S. So basically, you can't use it. You can't reuse the P because P is accessible from within the body. Okay, and it is said that values for the lambdas should be, to access from lambdas should be effectively final. So effectively final basically means that we're not being modified somewhere in between. So this is this string builder, this is all okay. It is local to modify the local instances like that, right? So basically reassigning, but not legal to reassign local values, right? X equal true. This is a private, right? And this is a field. So field is possible to change, but the local variable is not possible to change, because you basically reassign the local variable. And X is, since this X is a field in the class, so what you basically do, you reassign this variable for the instance. That's why it's possible, because you do a modification on this instance. And here you just basically reassign the variable. That's why it's not possible. Okay, so this was regarding the scope, and even more to confuse you, there are methods to actually use the method references. So basically, in order to even more simplify the usage of passing of functionality, for instance, for the static method, you might not use like this, lambda x argument going in and calling math cosinus, right? So basically, you can use math, 2 columns and cosinus, right? The same is for the instance methods. When you have s to upper, it can be replaced with something like that, right? Of course, this variable need to be accessible. Or for instance, like this, when you have a class method and this one is an argument, so basically you can define it like that. Right, this one's for the existing variable, this one's for the argument that can be passed in. Okay, and this is basically for the supplier that you can use new person. As well, this form can be used for that form as well if this person new actually accepts some variable. So these are examples. So for instance, math cost is basically a function which accepts double and returns a double, right? String uppercase is basically a supplier which provides a string a little bit modified, which is accessible in the scope. Parameter instance, yes, this is a function which accepts strings and returns strings, so basically can be written this way. And this is the option of a constructor. So if this constructor is considered as being a supplier, so it's basically an empty string called all the time. And if it's a function, it will accept string and return a new string based on the one you just provided. Okay. And basically that concludes the session. So basically looked into the lambdas expressions. So what to take away is a more concise way to use the anonymous instead of anonymous classes. Then these things, the lambdas, are actually based on the functional interfaces. And instead of creating your own functional interfaces, you can use interfaces coming from Java util function package. No new scope, access to effectively final variables, and raw method references. Okay, so basically these are the examples of various method references that we looked into a slide, and this is find person, and yeah, this is some more examples on various lambdas. Composite predicates, various compositions. Yes, various compositions when we can use default methods. So all of these examples are available for you. You can go ahead and find them out in the references somewhere. Okay, project, example, store, design, patterns, concurrency. I think if you would go into here, let's take a look. Okay, Java Technologies at FMI Wellness University. Yeah, we're at Lambdas and Streams. Lambdas and Streams projects are available for your convenience, so you can look it up, you can execute them, and so on. These are the examples I just showed you up. Okay, so 1 hour, 5 p.m. right on time. So this is what I expected. It is a shorter lecture. And I'm finishing the recording.